We are in Austin for Consensus, and today I'm gathered with John from Celestia. Hi, John.
Hello, Mia.
I want to start from the beginning because I am just getting to know you today. So I'd love to hear how you got into the industry.
Sure. So the kind of circumstances around this was that I was a graduate student at University of Toronto, doing research in a completely unrelated field, and then my grad school advisor happened to be very interested in blockchains. He was actually involved in the early days of Ethereum, involved in Bitcoin around those times as well.
What
Uh,
year was this?
which year was this? 2016, I think,
Okay.
around there. He was involved earlier. And then one picture he liked to show to his students was he took a selfie with the Mount Gox sign guy in Japan. Like when Mount Gox went bankrupt, there was like a guy in Japan like with a sign that said something along the lines of, give us back our Bitcoin, something like that. And then it was fairly famous, and my grad school advisor actually took a selfie with that guy.
Mm.
So he'd been around blockchain for a while, and he kind of slowly got his students, myself included, interested in blockchain technology. And then once I started reading the Bitcoin white paper, diving into the Ethereum virtual machine and stuff like that, then basically the rest was history.
What was your first? What did you work on first?
What did I work on first in the blockchain space?
Yeah, yeah.
Uh, that's a good question. The thing, well, there's something that I was interested in and something that I worked on. What I worked on was decentralized Oracle design. Back in those times, 2016, 2017, that kind of year, when the notion of smart contracts was still kind of new, coming up. Like Ethereum style smart contracts, there was a lot of talk around, you want to interface with real world data. Be this, real price of real world assets, stablecoin pegs, housing prices, let's say, if you have some tokenized house, weather stuff, sports results if you want to do some sort of on-chain gambling, ironically, stuff like that. So like interfacing real world data, bringing it into the blockchain was a very big topic at the time. So kind of the initial research that I did in the blockchain space was involved decentralized Oracle designs, crypto economic oracles. But what I was most interested in at the time was around designing state machines and virtual machines, because I was particularly interested in virtual machines and compilers, this kind of stuff. I took I don't know, maybe 6 different compilers classes and compiler optimization classes while I was in graduate school. So I was very interested in this topic. And kind of that's also where all my subsequent work was after I kind of left academia and joined Consensus. It was basically all in protocol design and designing virtual machines and state machines, that kind of stuff.
And how did you come up with the idea for Celestia?
So it wasn't actually my idea. It was Mustafa's idea.
Okay.
That's a good question. How did it? Well, I don't know how he came up with it, but he came up with it, and it was kind of this a very interesting take. It used to be called Lazy Ledger,
Okay.
and for what it's worth, I prefer the name Lazy Ledger because I think it's cute. But it was an interesting take because basically every other blockchain that you see in the market and advertised, blah blah blah, everywhere, they always propose more complexity to Bitcoin. They always say, okay, Bitcoin can't do something, so we're gonna add this feature. We're gonna add smart contracts. We're gonna add faster block times. We're gonna add this really complex consensus protocol that is magical and will solve scalability. And with every new professor coin and so on, it's always adding things, making things more complex. But Lazy Ledger was the first, and honestly, probably to this day, the only, really, ironically, even after Lazy Ledger, the paper came out 5 years ago. But it was the only blockchain that subtracted from Bitcoin, where it said, actually, Bitcoin is too complicated. It does too much, and it enshrines too many rules into its consensus. Let's take away some of those rules and make the blockchain simpler. And in making the blockchain simpler, it actually gets better properties for the properties that are important. It loses certain properties, yes, but it turns out those properties aren't needed at the base layer. They can instead be built at the application layer.
Why is Celestia important?
Why is Celestia important? So that to answer that, we should probably go why blockchains are important. Right? Which is that blockchains allow us to have some sort of self-sovereign, without the need for any particular state authority, way of kind of collectively acting and coordinating around some sort of set of values. For example, the cypherpunk values that kind of embody the origin of Bitcoin and Ethereum and potentially other chains, including Celestia. That's the kind of value that you can kind of coordinate around. And that's one of the reasons that blockchains in general are so important, is that you don't need a centralized state or just a centralized actor in general that has some sort of special authority to do things, and that you all kind of have to obey, or else. And this is especially important in a system of money. Bitcoin, well, it's debatable whether or not it's sound money, but let's say it's some sort of money. And it's a money that doesn't require any blessing or any authority from the state to function. And this is very important because while there are many people in the first world countries that have ready access to, say, US dollars and the American banking system, or banking systems in general, and also the US dollar, there are many people that don't have access to one or both. Right, they may have access to a banking system, but that banking system may be in some third world that may not actually be as highly regulated, and thus may not protect users as much as may be wanted. Stuff like that, right? And the ability, and like speaking from personal experience, I've actually personally been, despite the fact that I grew up in Canada. And lived in a first world country my whole life, basically. I'm one of the people that have experienced, and many people in the cryptocurrency industry have experienced, the bank freezing your bank accounts. Right? You're just there, you're doing a thing, and the bank decides for some reason. Usually, almost always, this reason doesn't make any sense, but there's some overly burdensome regulations. And then now you suddenly have no access to your bank. And you realize when that happens is you can't pay bills, you can't pay rent, you can't buy things in the grocery store because the credit card is frozen. You can't do anything, basically. There's so many, like you can't even get a hotel, because to get a hotel they're going to say, oh, okay, you need a credit card to put a deposit down. It's like, well, I don't have a credit card because it's frozen. I've been on the receiving end of this happening to me, and many people in the crypto industry have also had this happen to them, or to a friend, or just understand at a deep level that this is a thing that can happen even in the first world. So it's not the case that everyone has ready access to very strong banking systems. There's people in the third world country that just have no hope whatsoever to have access to American dollars in highly properly regulated and insured banking institutions. And for all of these people, what are they to do? They could trust their potentially corrupt third world government, or they could just deal with cash that can get debased very easily. Now good luck trying to do anything cross-border. So this is one of the reasons that Bitcoin was created, and one of the reasons that blockchain is so important, is that you can coordinate around some sort of shared set of values. Things like, I want money without needing to rely on a centralized government entity to administer that money and tell me how much money I have in a bank account and what I can do with it. And from that set of values, you can create a blockchain. So that kind of long-winded potential answer of why blockchain is important. Now, why is Celestia important? The reason it's important is that traditional blockchains, such as Bitcoin, such as Ethereum, face certain technical limitations. That doesn't necessarily mean that they have to go to the way of the dodo in the face of better technology. That's not necessarily true. So because technology is technology, and it's not necessarily the case that a better technology must win out. So before any Bitcoin maximalist says, oh well, there's better technology, therefore what are you saying, Bitcoin is worthless now? Well, not necessarily. There's value in certain networks that is independent of the technology. But we're talking purely from a technological perspective and not from a community perspective. Blockchains such as Bitcoin and others that came before Celestia, and others that came after Celestia, because like I said, Celestia is unique in its particular design direction, have certain shortcomings. What are those shortcomings? They don't scale as much as they could. In other words, given what is required to run the network, they don't support as many transactions. They don't have as much transactional throughput. So, Bitcoin, for instance, they say, okay, you're gonna run your full Bitcoin full node on this particular piece of hardware, and the Bitcoin network can support 1 megabyte every 10 minutes, and that's it. And it's not going to change anytime soon. I mean, technically it's 4 megabytes, but that's beside the point. So I guess it did change 1 megabyte to 4 megabyte. But let's say it's 1 megabyte. And that's not a large number of transactions. Like, you can't actually support a large number of users actually using the base chain in this way. Moreover, Bitcoin is also severely limited in what it can support in terms of smart contract functionality. So you can't have things like layer 2s on Bitcoin. You can't do that very well because the smart contract functionality on Bitcoin is severely limited and doesn't you can do it, but it's not amazing because the smart contract functionality on Bitcoin is not somewhat limited. It's very limited. Ethereum kind of did a different approach where they say, okay, let's have this very expressive smart contract programming environment, the Ethereum virtual machine. Very flexible, yes, but because of this flexibility, it also means that it's going to be slow. Or not slow, but rather slow for the particular constraint of you're going to run an Ethereum full node on this type of computer. So there's kind of basically untapped potential where these traditional blockchains designs essentially waste resources at the base layer that could instead be pushed up as requirements to the application layer. So what Celestia does that's unique is it says, okay, let's take all of these things that don't need to be in the base layer, all of this logic, and let's push it up to the application layer and make the base layer as simple as you can in a way that's optimal, in the sense that you can't have a blockchain that's better than Celestia. Not meaningfully better than Celestia, because it removes everything fundamentally that you don't need at the base layer. So you could have one that's maybe an incremental improvement, but you won't have one that's a 10x improvement, like how Celestia is, multiple orders of magnitude better than certain traditional blockchain designs because it removes this extraneous logic. And that's one of the reasons that Celestia is so important, is that it's a fundamental paradigm shift in how blockchains are done, and thus it results in greatly increased scalability to unlock new use cases, new applications, and new ways of coordinating, so that you can, coordinate around and create communities with this coordination around certain ideals, certain ways of thinking, like cypherpunkism, and basically make blockchains as good as they can be. So it doesn't. It's not like it enables. Well, it enables by being so much better than traditional blockchain designs. It can enable things, but ultimately it is a blockchain. So if you think blockchains are important, Celestia is a better blockchain design that allows you to kind of fully unlock the potential of blockchains and fully unlock being able to apply them to things that you may think are important.
And as you begin to build this, this feels very much like a 0 to 1 situation. Like you're building something that doesn't exist. Did you take reference from something?
I mean, it's true that it was a 0 to 1 in the sense that the protocol didn't exist. Did we take reference from something? Well, yes, in a few ways. So one of them was the Bitcoin design paper from like a philosophical perspective, right? The Bitcoin design paper describes a system for preventing the double spending problem. And the double spending problem, you don't really hear about it a lot nowadays, but back in 2017, people used to talk about it all the time. It was like, okay, blockchain is a solution to the double spending problem, right? Where it's like if you have two transactions or two attempts to spend a coin and they're conflicting, so the double spending, which one is the valid one, which one's the legitimate one. Blockchains are a mechanism to solve that problem. So the original Bitcoin design paper described a solution. Well, it described two solutions to that, I guess you could say. One of them was what ended up being implemented in Bitcoin, which is that you have a chain of blocks. Each block contains transactions, and only valid transactions are included in blocks. In other words, you resolve the double spending problem by only including you resolve the double spending problem by never including double spends in your blockchain. So that's what Bitcoin does. That's what all blockchains except for Celestia do, and potentially other data availability networks like Celestia that may be emerging that I may not be familiar with. But the kind of fundamental difference that Celestia does, it actually implements, and the lazy ledger idea fundamentally, it implements the solution that Satoshi proposed in the Bitcoin design paper. So like this was actually proposed in the Bitcoin design paper. It just wasn't expanded upon, and it wasn't caught on until Mustafa proposed it in the lazy ledger paper, which is that, and Satoshi himself proposes this, which is you can solve the double spending problem by including both spends and having a total ordering over them. In other words, as you can include both of them, just make sure there's an order, so you know which one comes first and which one comes second. And this is very different than traditional blockchain designs where you just don't include the second one. You explicitly exclude it. So with Celestia, you include both of them and you say, well, the first one is valid and the second one is not. And this kind of logic is actually application layer logic. Like if you're building a money system on top of Celestia, like let's say a Bitcoin rollup on top of Celestia, which you could totally do, right? Or an EVM based rollup, or a Solana virtual machine based rollup, and you're building some sort of like transactional blockchain on top of Celestia. That's the thing that's going to interpret the first one is valid and the second one is not Celestia itself. So you've essentially taken that logic of pruning out the second invalid spend, you've taken that and push it up into the application layer instead of leaving it on the base layer, making the base layer more optimized, because it doesn't have to care about the logic of is this valid or is this not. So essentially, like kind of the fundamental inspiration and base of Celestia was based on like a one paragraph in the Satoshi's Bitcoin white paper that describes the fundamental idea of Celestia, which is include both of them and just have an order between them.
Mm-hmm. And like as you begin to build this, I'm sure there was a point that it didn't look like the path wasn't clear, I imagine. So as you're building it, was there like a moment that you felt like, well, maybe this is impossible, or maybe like this big blocker is going to be a huge problem?
No.
No?
No. So that was never the case, actually. And I can tell a funny story, which is that I was a frequent poster and avid reader of ETH Research, the Ethereum Research Forum, back around those years, 2016, 2017, 2018, and then COVID happened, and then the whole world changed. But okay, but before then, I was kind of involved in a lot of kind of the early research around rollups, plasma, that kind of way of thinking, which was in the same direction as the lazy ledger idea at the time. It didn't really have that that flash of insight of you don't actually need to use a blockchain for excluding things and interpreting what is valid or not. You only need the blockchain to include everything and leave the interpretation of what is valid or not to application layer. That flash of insight wasn't there until Mustafa came around. So, but I was involved in the work that was heading in that direction. So one day I'm on ETH Research. I see this new post because I was there refreshing all the time. I see this new post by Mustafa. He posts and he says, here's a new design for a blockchain that requires sublinear validation. There's a bunch of academia and poor. We didn't have good ways of talking about these things like we do now, because this was 5 years ago. But they're talking about sublinear validation and all this other stuff. And I see the post is 5 minutes old. So I skim through it. I skim through the post. I'm like, oh, this is actually really interesting. Because I had been working in that direction. And then I click on the paper, I skim through the paper, and I'm like, oh wow, this is exactly how you should do blockchains. This is it. This is the real deal. And then I go on his Twitter and I see that he's active on Twitter, but he hadn't posted about this particular thing. He had posted about all the blockchain stuff, but he hadn't posted about this particular thing, which I thought was odd. So I'm like, I start writing a tweet, and I'm gonna tweet out about this ETH Research Forum post because it's so interesting. And look, this is how you should do blockchains. So I type my tweet and I send it and I hit refresh, and I see in my timeline that he had posted his tweet a few seconds before mine got posted, which basically means as I was writing my tweet, he was also writing his tweet.
Oh, wow.
And then since then, it's basically been like wild ride of co-founding Celestia with him and Ismail. Building up a team at Celestia Labs to be one of the core dev entities. And no point did I ever think from that beginning that this was the wrong way of doing things, or this wouldn't have a chance of working, anything like that. It was always like, this is 100% going to work, and there is no second best. As kind of, I mean, I don't know if we should do that, should use that expression, given that Sailor was wrong and there was actually second best. But it was basically like it was 100% sure for me that this is the way to build blockchains, and there was no fundamental problems with, or open questions with any of the design from day one. It was all like, we just have to implement this.
Wow, that's such a unique way of meeting a co-founder. And how did you meet the third one?
Mustafa connected us, or I guess he had connections with Ismail, not myself.
Okay. So, okay, three people come together. I guess they both knew each other from before.
Yes.
And how, I mean, there's so many questions, like founders, like there's so much around like building something together, like compatibility. Was there any clash? You just like instantly clicked?
I would say so, yeah. We're
Yeah.
all chill guys.
And you work like remotely from different cities?
Yes.
That's unbelievable. And like full time from the beginning.
Yes. I've heard a lot of horror stories in crypto of founders having like terrible fallouts and like, oh, so much drama. And outside of crypto too. I mean, you saw OpenAI with Sam Altman, right? So like, there's everyone's drama and everyone has egos and stuff. But yeah, everything just went smoothly for us.
People come together from like this incredibly unique vision at the time, right? And then you begin to build this. Was always like, did you always carry this conviction that it would work?
Yes, from day one, from that time that I was tweeting about it, from the time but even before that, even like from the time I opened that post and read the Lazy Ledger white paper, I was like, this is it. This is how you build a blockchain.
Mm-hmm.
This is amazing. Like, this is how you build a blockchain. And then everything else, like I said, there was no open questions fundamentally. There was like, oh, we designed some things and have invariants in the state machine, and then we literally just go and we just implement it. And it took a while because, as it turns out, some of the things that Celestia implements, such as data availability sampling, are not easy to implement. And that's why Celestia is the only blockchain in production today that has some of those features. And it's like not even close. It's not even close with respect to like this, the next one that's closest is still like a long ways away from having data availability sampling and reconstruction and all the stuff that's necessary to be secure. So like literally it was just, this is the right way of building blockchains. No, like my conviction is completely unshakable, and we just have to implement it.
And those who don't share the same conviction, what are the most common arguments?
What are the most common arguments? I mean, I guess we'll find out tomorrow in my fireside chat with Austin from
yes.
Solana.
Yeah, so you're having a fireside chat during the conference with...
Yes. Oh, no, today, actually.
Today. All right.
So tune in for that if you want to know what the biggest anti-proponents of modular blockchains say.
But is there like a prominent one that you can mention? And because my next question would be like, how do you counter-argument that?
Yeah. There's counter arguments for everything. One of the bigger, let's say one of the, let's go with one of the counter arguments. Maybe, I mean, I'm sure if I hear from Austin directly, it'll be more obvious, because right now I'm just kind of imagining what they'll say. One of the arguments may be around fragmentation. Things like, oh, you have a bunch of applications. How do these applications interact with each other? I mean, that's an interesting argument, but also, in my opinion, a lot of these things you should just let the free market decide, because let's say you have a really fast monolithic blockchain like Solana. You say, okay, you don't have to worry about cross application and cross rollup and cross blockchain communication. You're all on one blockchain. Well, as it turns out, that people are building rollups in Solana because they find that Solana is potentially insufficiently expressive in the Solana virtual machine, and they want more throughput. They want all their properties that are application specific, etc. So okay, let's build a rollup on Solana, or let's build like an L2 on Solana, and there's a number of these that are popping up. But there's also nothing stopping you from building Solana on Ethereum. Like if you say people should only use a single state machine a single virtual machine, and they should all share state. Okay, then build Solana on top of Celestia. And then don't build any other rollup. Just build the application. And if that's actually the best, don't argue about that with me. Let the free market decide. Right? Like, if that is actually the best, then the free market should converge to this. If the free market converges to a quote-unquote fractured ecosystem that requires cross-chain communication, then clearly the monolithic approach is not best. But anything that any blockchain can build in terms of a shared state machine, so like the Solana virtual machine, for instance, the Ethereum virtual machine, the Near virtual machine, the Bitcoin virtual machine, even like the Bitcoin script, any kind of state machine that you can envision, you can just build that as an application, as a rollup, sovereign-based ZK with a ZK account rollup. You can build it as a rollup on top of Celestia. Back in the early days, before we had like a bunch of nomenclature, I would call Celestia like a universal blockchain, because you can build any blockchain on top of Celestia as a base. And you can do this because it's agnostic, because it doesn't take any opinions around what logic is valid or not valid. It just says, okay, applications, you define your own logic. And that logic could be, for instance, Solana virtual machine. So like if there's any proponent of the notion of, everyone should be in a single shared state, and that's the best way of doing things, and then I'll say, maybe that is, but that is not contradictory to the modular thesis, because the modular thesis is not necessarily about you must have a bunch of fragmented layers. It's about build in layers, not the applications must be fragmented. It's allowing the applications to be fragmented, but letting the free market decide. So you have choice. And by you, I mean the market is choice. So the kind of one big argument that I've heard against modular blockchains and stuff like Celestia, as opposed to monolithic blockchains, is this kind of fragmentation issue. But like I said, it's not a fundamental issue, and it's a thing where if it's an actual issue, then the free market can decide, but the free market can still decide to go modular with a single shared state machine on top of a modular base.
Is there anything exciting coming up for Celestia?
Is there anything exciting? So there's this thing called modular expansion, which is going to be the theme of Modular Summit coming up in Brussels in a couple of months, which is basically that you can think of the launch of Celestia like the Big Bang. It was, I guess, started from nothing, kind of echoing what you said earlier. Where it's like, okay, we start, there's nothing, boom, Celestia has launched, the Big Bang, and then the universe expands. Similarly, the modular ecosystem has been expanding, and in the first 6 months, now it's been like 6 months and change since Celestia launched, right? Chains were spinning up, integrations were being built, people were getting excited about building on Celestia and the modular narrative and the ecosystem, etc., and things were getting built. And now, increasingly, we're seeing people becoming increasingly modular pilled, moving their stacks and supporting Celestia and other modular components and like design philosophy and stuff like that. And things are getting launched more and more. And that's kind of the notion of modular expansion, whereas like the modular ecosystem is growing and growing visibly, kind of like how the universe is expanding after the Big Bang. And then like a bunch of projects are kind of coming on board onto the modular ecosystem. So I don't know them all, because I don't do ecosystem tracking. You'd have to ask the ecosystem tracking person for this, right? But there's a number of projects that are kind of getting started as sovereign rollups on Celestia. There was, I think, the first sovereign rollup on Celestia that launched with Astria a few days ago, or one day ago, or something extremely recently. The name is escaping me, but it was on Twitter. So that's an example where it's like sovereign rollups, which weren't a thing prior to Celestia, really. It was all about smart contract rollups and using a settlement layer like Ethereum and stuff. But like, you don't need that. You just build a sovereign rollup on top of Celestia that's sovereign to itself and its own values, and it can just use Celestia as a data availability layer without enshrining settlement to some third party. They can be sovereign to themselves. Right? That community can be sovereign to themselves. There's various rollups that have previously and currently settled to Ethereum that are kind of enabling for their layer 3s and their kind of layer 2 with their SDKs and frameworks and stuff, modular data availability networks that users can choose if they want to spin up a new chain. Things like Arbitrum Orbit L3s, for instance, which is kind of the first the first integration that supports fraud proofs, and that uses Celestia, that supports Celestia for data availability instead of just Ethereum call data, as an example. Right, so there's basically an ever increasing number of ecosystem projects, and the ecosystem is kind of expanding day by day, and that's, I think, one thing that people can be excited to look forward to.
When I first heard of Celestia, I was really excited about it. I like the idea of like simplifying things rather than making them more complex. And so my mom had just like rescued a cat, and I named her Celestia. So I thought I would like share that with you. For everyone watching, where can they find you?
You can find me on. Well, hopefully you mean how you can find me online.
On like Twitter, on Twitter. Yeah.
Not in person. Like, don't dox my location. You can find me on Twitter at jadler0. Unfortunately, I don't look like a cute anime girl in real life, like my PFP is. I don't think I have any other social media accounts, so the best place to find me is on Twitter, at jadler0.
John, thank you.
Thank you for having me.